Hello guys, here we will study the alcohol, phenol and ether topic. In this topic, the alcohol, it should be completed. Now in today's lecture, we will start the phenol. Okay. Then phenol, it is a hydroxy derivative of aromatic compounds. It is a hydroxy derivative of aromatic compound. That means the aromatic compound get converted into phenol. That means if hydroxyl group is directly attached to aromatic compound or aromatic ring, and here we consider the aromatic ring, first aromatic ring or general aromatic ring we here consider as a benzene. That means that if hydroxyl group is directly attached to aromatic ring, here we consider aromatic ring means here we consider the benzene. That means this is a revised definition. Once again I will tell you. If it is a hydroxy derivative of benzene or aromatic compound, it is called as a phenol. That means the hydroxyl group is directly attached to benzene. Then this is known as a phenol. This is a phenol. Okay. Then in this case, the phenol, it is also called as a carbolic acid. The phenol, it is also called as a carbolic acid. Okay. Then this is a phenol, or simplest or easily we also know the phenol. Phenol means a hydroxy derivative of aromatic compound that or the hydroxyl group is directly attached to benzene ring. Okay guys. Then this is a phenol. Then after that we consider the classification or study the classification of phenol. Okay. In case of phenol, the phenol is, this is a classification of phenol. Okay. The phenol is classified into mainly three types. Okay. That means in this case, in case of phenol, that is a monohydric phenol, dihydric phenol and trihydric phenol. Okay. These three types, that means first one is a monohydric, second one is a dihydric and third one is a trihydric phenol. This one is a monohydric phenol. Second one is a dihydric phenol. And third one is a trihydric phenol. Okay, monohydric phenol, dihydric phenol and trihydric phenol. Mono means single, hydric means OH group. Okay, this classification is near about similar with classification of alcohol. Okay, that means in this case, in alcohol is classified into monohydric alcohol, dihydric alcohol, trihydric, that means a polyhydric alcohol. Similarly, here phenol is again classified into mainly three types. Out of these, first one is a monohydric phenol, second one is a dihydric phenol, and third one is a trihydric phenol. Okay. In case of monohydric phenol, mono means a single, hydric means hydroxyl group. That means if the hydroxyl group, a single hydroxyl group is attached directly to the aromatic ring, it is called as a monohydric alcohol. In this case, firstly we consider the example of this is a directly this compound is known as a phenol. Or one hydroxyl group is attached to this type of aromatic ring, that means this is a CH3. Okay, and to this molecule, the one hydroxyl group is attached here. Then here we also consider the another example. This example is right here. This is a OH, this is a CH3 group is attached here. Then here, if the CH3 group is attached to the opposite side of hydroxyl group. Okay, these are some examples of monohydric alcohol. In this alcohol, the monohydric phenol, this is a name of this compound, it is a phenol, commonly it is known as a phenol. This one is a orthocrisol. This one is a orthocrisol, that means a orthomethyl phenol. This one is a orthomethyl. That means in case of IUPAC nomenclature, we goes numbering goes second number goes to the methyl group and first number goes to the hydroxyl group according to priority sequence of functional group. Therefore, this orthocresol is also known as a 2-methyl phenol. 2-methyl phenol. Okay. Then here consider this example. This is a metacresol. This is a metacresol. Then IUPAC nomenclature, the first number goes to the hydroxyl group, first, second, and this one is the third. That means the methyl group is attached to the third number of benzene ring, third number of carbon atom which contains the from the benzene ring. Therefore, the IUPAC name of the metacresol is that 3-methyl phenol. Is that 3-methyl phenol, and this one is also considered as a paracresol. IUPAC nomenclature is that a 4-methyl phenol. IUPAC nomenclature is that a 4-methyl phenol. Okay. These are the examples of monohydric alcohol. In this monohydric alcohol, there are only one hydroxyl group is attached here. Therefore, it is classified into monohydric alcohol. Now we go towards the dihydric alcohol. Okay. In case of dihydric alcohol, di means two. Di means two. Hydric means hydroxyl group. If in case of two hydroxyl group is attached to the benzene or aromatic ring, then it is called as a dihydric phenol. Okay. In this case, there is a benzene. To this benzene there is a one OH group and another OH group is attached here. Okay. The common name of this compound or special name of this compound, it is a catechol. This is a catechol. Okay. Or it is also known as a 1,2-dihydroxy benzene or ortho-dihydroxy benzene. These are the three names of the compound. This catechol, it is a special name. In this case, there are two hydroxyl groups are attached here. Okay. Then here we also consider this is a OH and OH group is attached to this carbon atom. Then to this carbon atom, continue OH group and this OH group attached to this carbon atom. The name or special name of this compound is a resorcinol. Spelling is if it is a right resorcinol, it is a resorcinol. Okay, spelling is right here. This is a resorcinol. Or name of this compound, IUPAC name of this compound is A. Numbering goes to the one. First numbering goes to the hydroxyl group. Second one and third one is A. That means, or if numbering goes started towards the 1, 2, 3, or also started with 1, 2, 3. Okay, the name of this compound is a 1,3-dihydroxy benzene. 1,3-dihydroxy benzene. Or this hydroxyl group, here we consider this hydroxyl group. This hydroxyl group is attached to the meta position of phenol. Or if this hydroxyl group considered here, then this group, this hydroxyl group is attached to the meta position to considering this a phenol. Okay, then it is a meta-dihydroxy benzene is here. That is a meta-dihydroxy benzene. Now, third example is that a hydroxyl group is attached to this type of carbon atom. It is known as a quinol. It is known as a quinol. Okay, it is also known as a quinol, or it is also known as, this quinol is a special name. It is a para-dihydroxy benzene, or it is also called as a 1,4-dihydroxy benzene. 1,4-dihydroxy benzene. Okay. Then in these three examples, there are two hydroxyl groups are present in each. Three hydroxyl group is attached to each benzene ring, therefore it is classified into dihydric phenol. Okay. Then now we consider, or we goes towards the trihydric alcohol. Now we also clear that what is meant by trihydric alcohol. The trihydric alcohol, that means the 3-hydroxyl group is attached to the benzene ring. It is called as a trihydric alcohol. Okay. In this case, there are 3 hydroxyl group is attached to benzene ring. Okay. First one is attached to this, second one is attached to this carbon atom, and third one is attached to this carbon atom. That means that each hydroxyl group is attached to the benzene ring in alternate position. Therefore, the common name of, or special name of this compound, it is a fluoroglucinol. Common name of this, or special name of compound is a fluoroglucinol, or it is also called as a benzene 1,3,5-triol. Benzene 1,3,5-triol. Okay. Then another example is a 3-hydroxyl group is attached to each adjacent carbon atom. Okay. Then special name of this compound is a pyrogalol. Pyrogalol. Okay. Pyrogalol. This is a O. Okay. The IUPAC nomenclature of this compound, it is a, the numbering was started from this hydroxy group. This one number goes to this hydroxy group. This is second, and this one is a third. That means the IUPAC nomenclature of this compound, it is a benzene 1,2,3-triol. Benzene 1,2,3-triol. And another example is that this is a benzene. To this benzene 1 hydroxyl and 2 hydroxyl group is attached to 2 adjacent carbon atom, and third hydroxyl group is attached to the fourth number of carbon atom. The name of this compound, it is a benzene 1,2,4-triol. Benzene 1,2,4-triol. Okay, guys, this is a classification of phenol. In this classification, or phenol is also known as a carbolic acid. This carbolic acid word is important for many examination. Then phenol, it is a hydroxyl derivative of aromatic compound. Then classification of phenol. The phenol is classified into monohydric alcohol. In this phenol, in this type of phenol, one hydroxyl group is directly attached to the benzene ring. Then second type is a dihydric phenol. In this phenol, there are 2 hydroxyl groups is directly attached to the benzene ring. In this case, there are 3 hydroxyl groups is attached to the aromatic ring. Therefore, it is a monohydric, dihydric, as well as it is a trihydric alcohol. Okay, guys. Then after that, we also show the structure of phenol. Okay, the next point is a structure of phenol. Okay, the phenol, it is a hydroxyl derivative. This is a phenol double bonded benzene. That means the hydroxyl group is directly attached to the benzene ring. In this structure of phenol, this hydroxyl group contains some oxygen atom. This oxygen carries the lone pair. That means this oxygen, it is a electron rich species because oxygen carries the lone pair atom. Then this lone pair is directly attached to the carbon atom. This carbon atom is in sp2 hybridization. This carbon atom is a sp2 hybridization. That means this hydroxyl group is directly attached to the doubly bonded carbon atom. Okay. Then this benzene shows the conjugated system. That means in this benzene ring there is an alternate single double bond is also shown here. Okay. Then this oxygen which carries a lone pair. Then here firstly we show the single bond between carbon and oxygen atom. Okay. Then after the lone pair of the oxygen atom is involved in conjugation, is involved in conjugation. That means this double bond, this lone pair of oxygen atom is involved in a conjugated system. Then after conjugation, here between carbon and oxygen atom, there are double bond is also formed. That means there is a formation of this type of structure. Here, this is a double bond. Okay, it shows the lone pair hydrogen atom. It should be eliminated, and here it shows the negative charge. Then double bond is here. That means the single bond carbon oxygen, it is a single bond. Then single bond get converted into double bond. Then double bond, single bond it get converted into double bond. That means the bond length it goes on decreases. That means the bond length it goes on decreases. Then this bond length it is a 136 picometer. Bond length is a 136 picometer, and into this respective bond length, the bond between carbon and oxygen atom, it is the strongest bond. Due to this bond or new bond is formed in the conjugation after involvement of lone pair of oxygen in the conjugated system. After conjugated system, there is a double bond is here. The bond length of the carbon oxygen bond, the bond length of the carbon oxygen bond, it is a 136 picometer. Okay. Then this oxygen carries lone pair. That means the bond angle between hydrogen, oxygen and carbon atom. The bond angle between oxygen, hydrogen and carbon atom, this bond angle it is a 109 degree. Okay, the bond angle between carbon oxygen hydrogen or hydrogen oxygen carbon, it is a bond angle, it is a 109 degree, as well as the bond length between carbon and oxygen atom, it is a 136 picometer. Okay, as well as the phenol is more acidic than alcohol. Phenol, it is a more acidic than alcohol. Okay. Then this acidic character is shown shown in next lecture. Then this is the most important sentence: phenol is more acidic than alcohol. Okay. Then due to this characteristic, the phenol it shows the electrophilic substitution reaction. Phenol shows the electrophilic substitution reaction. Okay, guys. This is the structure of phenol. In this point or in this concept, there are hydroxyl group is directly attached to the sp2 hybridized carbon atom. sp2 hybridized carbon atom means the carbon contains a double bonded carbon atom is here. Therefore, the oxygen carries a lone pair. Then these lone pairs are also involved in conjugated system, and this phenol shows the resonating structure. After resonating structure, there is a double bond is also formed in between carbon and oxygen atom. And if the double bond, or if in case of resonating structure, the carbon oxygen it shows the double bond. The double bond having a greater bond strength than a single bond. Therefore, this bond is not easily break down. That means the double bond which is formed in the resonating structure, it is a strongest bond. Therefore, it is a not easily break down. Okay. Then it is a single bond is here. We consider here the single bond between carbon and oxygen atom. The bond length between carbon and single bond between carbon and oxygen atom. The length of bond angle is a 136 picometer, and bond angle between carbon oxygen hydrogen or hydrogen oxygen carbon, it is a 109 degree. Okay, and last and most important point is that phenol is more acidic than alcohol, as well as the phenol shows the electrophilic substitution reaction. Okay, at ortho and para position. Okay, electrophilic substitution reaction is shown at ortho and para position. Okay, then here we consider the preparation methods of phenol. Preparation method of phenol. Okay, the first preparation method. This preparation methods is important preparation methods. preparation methods of phenol. Okay. Before studying the preparation methods of phenol, firstly we study the introduction as well as structure of phenol as well as classification of phenol. Okay. Then after that we start here the preparation methods of phenol. Okay. In this preparation method, the first method, it is a Dawes process. It is a Dawes process. Okay. Dawes process, it is a industrial preparation method of phenol. Dawes process, it is a industrial preparation method of phenol. Okay. In this Dawes process, there are chlorobenzene is used as a first reactor, but this chlorobenzene is prepared from benzene. Okay, then here we consider the benzene. The benzene get converted into chlorobenzene. That means here a electrophilic substitution reaction. That means the chlorine shows the chlorine act as a electrophile, and this benzene shows the electrophilic substitution reaction. But this chlorine is not directly attached to this benzene ring. Therefore, any FeCl3 is used as a catalyst. This catalyst or this FeCl3 is known as a electrophile generator. Okay, this FeCl3, it generates the electrophile, that means it generates the Cl plus, and this Cl plus is attached to the benzene ring. After attachment, there is a formation of chlorobenzene. This is a preparation method of chlorobenzene from benzene. Okay, then this reaction we will show in the 11th standard in aromatic compound. Okay, then by using this reaction we prepare the chlorobenzene. Then this chlorobenzene is used here. Okay. Then this chlorobenzene is a heated with aqueous alkaline solution. Aqueous solution, that is aqueous NaOH. Here we also consider the aqueous KOH. Firstly we understand the reaction, after that we go towards the mechanism. This reaction is also carried out at 613 Kelvin temperature under 300 atmospheric pressure. This is a commercial preparation method or industrial preparation method of phenol from chlorobenzene. Okay. Then at higher temperature, at a higher pressure, this chlorobenzene get converted into sodium salt of phenoxide ion. It get converted into sodium salt of phenoxide ion. Okay, this is a sodium salt of phenoxide ion. Okay, sodium salt of phenoxide ion. Okay, this is a first step. Okay, this is a first step. This one is a second step. In second step, there is a sodium salt of phenoxide ion. This is a sodium salt of phenoxide ion is heated with a dilute HCl. Heated with dilute HCl. From this dilute HCl heated due to heating, the bond between H and Cl is break down. There is a NaCl is eliminated, and this hydrogen is directly attached to the oxygen atom, and there is a formation of a phenol plus HCl is also formed. HCl is also formed. Okay, but in this step there is a formation of water molecule. Okay, then by using this step, the sodium phenoxide ion is heated with dilute HCl, or the alternate of this second step, we also use the another method to preparation of phenol from sodium salt of phenoxide ion. Then this step is alternative to this second step. Then here we also write the sodium salt of phenoxide ion. This is a O minus, this is a Na plus. This sodium salt of phenoxide ion is a passing through this CO2 gas. Okay, but in this case the sodium salt of phenoxide ion is in aqueous medium. That means firstly this sodium phenoxide ion is dissolved in water. That means the aqueous medium of sodium salt of phenoxide ion, and from this aqueous medium of sodium salt of phenoxide ion, aqua, that means the water is right here. Then aqueous solution of sodium salt of phenoxide ion. From this aqueous solution of sodium salt of phenoxide ion, the CO2 gas is passing, or CO2 gas is passed through this solution, and then it forms the sodium. Then it forms a phenol. Okay. As well as here we also get the NaCO3, that is a sodium bicarbonate. This sodium bicarbonate, it is a valuable product is here also formed. Okay. In this case, that means in Dawes process, this Dawes process is not included in NCERT or as well as in CBSE board examination. This is in CBSE there is they give this preparation method. Then this is a Dawes process. This Dawes process, that means it is a commercial preparation method of phenol from chlorobenzene. In first step, chlorobenzene is reacted with aqueous NaOH at 613 Kelvin under 300 atmospheric pressure. Then it forms a sodium phenoxide ion. Then this sodium phenoxide ion is heated with dilute HCl. Then it forms the phenol, as well as the phenoxide ion, the aqueous solution of phenoxide ion. From this solution, the CO2 gas is passed, and after passing of CO2 gas, there is a formation of phenol as well as a valuable byproduct, that is the sodium bicarbonate, is also formed here. Okay. Then this is a reaction of Dawes process. In this first step is also common, but second step it is a alternative steps. Okay. Here if we also write this second step, then we also got the phenol, or write this second step, there is also we got the phenol. Okay. Now we goes towards the mechanism of Dawes process. Okay. This is a chlorobenzene. Okay. This chlorobenzene, here we write here the one hydrogen is here, or this hydrogen is considered is also here. Then it is reacted with NaOH. NaOH, it is act as the strongest base, or instead of NaOH we can also use the KOH. The KOH will also act as the strongest base. That means it gives the OH minus. That is, it gives the OH minus ion, or it also known as a base. Okay, NaOH. Okay, here right here Na plus and OH minus, because NaOH is act as the strongest base. This OH minus. Okay, this OH minus act as a base. That means it abstracts the acidic hydrogen. It abstracts the proton. It abstracts the H plus ion. Here we consider the hydrogen of this carbon atom. This hydrogen is an acidic medium due to the electronegativity of chlorine atom. This chlorine withdraws the electron towards itself, and this hydrogen is present in H plus ion. That means this hydrogen shows in acidic nature. Therefore, this hydroxyl group attacks on this H plus ion. Or that after abstraction of OH minus ion, there is a negative charged carbon. That means this bond, that means the one lone electron pair is involved in the bonding between carbon and hydrogen atom. It involves on the carbon atom. There is a formation of, water molecule is eliminated here. There is a formation of a, this is a double bond, this one is also series here. This carbon shows the negative charge, or the change the position of double bond to better understanding. This is double bond is here, double bond, and double bond is here. Okay. Then this negative charge carbon atom, that means on this carbon atom there is a one lone pair is excess, but here the Cl is considered as a base leaving group, because halogen is act as a base leaving group. Therefore, this negative charge is delocalized in between this carbon atom and this carbon atom. At that same time, the Cl minus it should be eliminated. The eliminated Cl minus, and here is present in Na plus. The Na plus and Cl minus combine with each other, and then it forms the NaCl. Here the NaCl is formed here and right here. That means there is a formation of triple bond. There is a formation of triple bond. Here double bond, sorry, this is a triple bond is here, double bond and double bond is here. The name of this compound is a benzene. The name of this compound it is a benzene, and this benzene it is a intermediate or conversion of chlorobenzene into phenol. In Dow's process, this reaction is carried out through formation of benzene. Okay, this is a benzene. Okay, benzene contains the triple bond. In this benzene, the benzene it does not shows the physical properties or properties of benzene. Okay, therefore this pi bond, the excess pi bond, out of this triple bond, 1 pi bond, 2 pi bond is here. Out of this 2 pi bond, 1 pi bond is delocalized or is goes towards the or delocalized on the adjacent carbon atom. Okay, then there is a formation of, this is a benzene, and this benzene shows the negative charge. Okay, then this benzene is reacted with second molecule of NaOH, because here the NaOH is present in aqueous medium. That means NaOH is present in excess quantity. Then first molecule is involved here, and another molecule is also involved here. Okay, then this OH minus. Okay, here we also write NaOH. Okay. Okay. This is a double bond. Here, the negative charge present on this carbon atom. After delocalization, this carbon, that means this carbon should be positive charge. This carbon should be positive charge. Okay. This reaction is carried out in presence of heating at 613 Kelvin. Therefore, here OH minus is also act as a base. Therefore, after bond breaking, there is a formation of Na plus and OH minus. This OH minus attacks on the carbocation, because after delocalization of pi bond on the carbon atom, this carbon atom bond pair get converted into lone pair. Therefore, this carbon shows the negative charge, and this carbon shows the positive charge. On this positive charge, the OH minus attacks on here, and there is a formation of this carbon also shows the negative charge. This is a O, this is a H is here. This is a double bond, this one is a double bond. And this carbon shows the negative charge, that means one lone pair is extra present on this carbon atom. To maintain the or to remove the negative charge from this carbon atom required one more hydrogen, and this hydrogen is directly attached to the oxygen atom. Therefore, this hydrogen is present in a acidic nature. Therefore, this negative charge oxygen attacks on the H plus ion. At that same time, the bond between oxygen and hydrogen atom is delocalized on the oxygen atom, and then it forms a. Here hydrogen is here. That means the benzene is remains as it is. Here oxygen shows a one lone pair extra. Therefore, this oxygen shows the negative charge. Okay. Then this negative charge, there is a formation of phenoxide ion. There is a formation of phenoxide ion. Then this phenoxide ion is again reacted with dilute HCl. Out of this dilute HCl, the O minus, by using their one extra lone pair, this attacks on the H plus ion, and there is a formation of a phenol. There is a formation of a phenol. This hydrogen is also one of the part of carbon atom. This hydrogen maintains the valency of carbon atom. Therefore, this hydrogen atom is not shown in this benzene. Okay, there is a formation of phenol, and remaining Cl minus, and here Na plus is also stay here. Okay, then this Na plus and this Cl minus is combined with each other, and there is a formation of NaCl. There is a formation of NaCl. Okay, this is a mechanism of Dow's process. Dow's process is carried out in mainly two steps. In the first step, the chlorobenzene is heated with aqueous NaOH or aqueous KOH at 613 Kelvin at 300 atmospheric pressure. There is the formation of a sodium salt of phenoxide ion. After that, it also heated with dilute HCl or CO2 gas is passing through the aqueous solution of sodium salt of phenoxide ion. There is a formation of phenol. Okay, but one of the most important part of this reaction mechanism is the formation of phenol from the chlorobenzene, specifically which is included in those process. In those process, chlorobenzene get converted into phenol through the formation of benzoate. The many questions are asked on this benzene. Okay, formation of phenol from chlorobenzene in those process through benzene. Okay, this is a mechanism of Dawes process. Okay, then next preparation method is that a Raschig process. A Raschig process. Raschig process. By using this process, we also conversion of phenol from chlorobenzene. Here in this process, here chlorobenzene is also used here. But in this reaction, the chlorobenzene is heated with water. Chlorobenzene is heated with water at 698 Kelvin. The temperature should be slightly greater than the Dawes process. The chlorobenzene is heated with water at 698 Kelvin, but this reaction is carried out in presence of catalyst. This reaction is carried out in presence of catalyst. That means first catalyst is used as a silicon dioxide or a calcium phosphate, Ca3PO4 twice. Okay. This silicon dioxide and calcium phosphate is act as a catalyst, and then it forms a phenol. Then it forms a phenol plus HCl. Yes, it is a HCl is also formed. Here it is known as a phenol, and this one is a chlorobenzene. This one is a chlorobenzene. Okay. This silicon dioxide and calcium phosphate is act as a catalyst. This catalyst is not directly involved in this reaction. Then this temperature will break the bond between what H plus and OH minus ion. This OH minus is attached here, and this Cl minus and H plus is attached with each other. Then it forms the HCl. Okay. This is also industrial preparation method of phenol from chlorobenzene. Okay, guys. Then we also show the another preparation method of phenol. Okay. In this preparation method, we can also use the benzene. We can also use the benzene. Okay. In this benzene, or to this benzene, or this preparation method from the preparation of phenol from benzene sulfonic acid. From this reaction is carried out from benzene sulfonic acid. This is a benzene and sulfonic acid. That means SO3H group is directly attached to the phenol. Directly attached to the benzene ring. This benzene sulfonic acid is prepared from sulfonation of benzene. That means this benzene is reacted with a oleum, that is H2S2O7. This H2S2O7, that means a fuming H2SO4. That means it is also formed by the mixing of H2SO4 and SO3, then it forms H2S2O7. This is a oleum. This oleum, by using this oleum, the benzene, it undergoes sulfonation reaction. Then it forms a benzene sulfonic acid. Okay. Then this benzene sulfonic acid is used to preparation of phenol. Okay. Then here firstly we consider the benzene sulfonic acid. This benzene sulfonic acid is SO3H. Okay, this is a benzene sulfonic acid. This benzene sulfonic acid neutralize. This is an acid. To neutralize to acid, we can use a base, a strongest base, because this sulfonic acid is the strongest base. To neutralization of this sulfonic acid, we can also use the strongest base, that is the NaOH. This NaOH is neutralizes to the benzene sulfonic acid. Then this H plus and this is OH minus. This OH minus acts as the strongest base. Our NaOH acts as the strongest base. Therefore, this OH minus is attacks on the H plus ion. There is a formation of water molecule. Okay, and after elimination of H plus ion, this Na plus ion is attached to the sulfonate group. There is a formation of a sodium salt of benzene sulfonic acid. There is a formation of sodium salt of sulfonic acid. Okay. After that, this is a sodium salt of sulfonic acid. This is a sodium salt of benzene sulfonic acid, and this one is a benzene sulfonic acid. Okay. There is a formation of sodium salt of benzene sulfonic acid. Then this sodium salt of benzene sulfonic acid, this is the sodium salt of benzene sulfonic acid, is fused with NaOH. In first step, there is a neutralization reaction is here. This benzene sulfonic acid is neutralized by using NaOH, and in second step, by using a NaOH, this NaOH is fused with a sodium salt of benzene sulfonic acid at 573 Kelvin. Then it forms a sodium salt of phenoxide ion plus Na2SO3 should be eliminated, plus HCl is also formed. H2 is also formed. Okay, this is a formation of sodium salt of phenoxide ion. And from this sodium salt of phenoxide ion, we can also easily prepare the phenol. Okay. In third step, this sodium salt of phenoxide ion. This is the third step. The sodium salt of phenoxide ion is heated with dilute HCl. Then it forms a phenol plus HCl is here. Then it forms a phenol. After heating, there is a bond which should be break down between H and Cl minus. This Cl minus combined with the Na plus, there is a formation of NaCl. Okay, here we write the NaCl, and this H plus is comes towards the OH minus, and there is a formation of phenol. Okay, then this is a third step. In first step, there is a neutralization step. In second step, it is a fusion step. That means in second step, the sodium salt of benzene sulfonic acid is fused with NaOH as 573 Kelvin. That is the formation of sodium salt of phenoxide ion. Okay. Or instead of this third step, we also use, instead of dilute HCl, we can also use the H2SO4. That means a phenol. Here in this step, there are two molecules of phenol is also required. For two molecules of H2SO4, then it forms, sorry, here O minus Na plus, there is a two molecules of sodium salt of phenoxide is used here, and this is the H2SO4. H2SO4 is used here because H2SO4 acts as the strongest acid, therefore it donates the H plus ion easily. Therefore this H plus ion combined with OH minus ion, then it forms a phenol, two molecules of phenol, plus here also forms the Na2SO4. Here it also forms the Na2SO4. Okay, then this is a third step which can be also used instead of reaction of sodium salt of phenoxide ion with HCl, and for this step we can also use this alternative stage. The sodium salt of phenoxide ion is also reacted with H2SO4. H2SO4 acts as a strongest acid. Due to this strongest acid, it donates the H plus ion easily, therefore it converted the sodium salt of phenoxide ion into phenol easily. Okay, this is some preparation methods of phenol. In this lecture we will study the preparation method. We studied the Dawes process, Raschig process, and the preparation of phenol from benzene sulfonic acid. This benzene sulfonic acid is prepared from the benzene. It undergoes the sulfonation reaction. This sulfonation reaction we will study. We will study it in 11th standard in aromatic compound. Okay. Then these are the some important preparation methods, and remaining preparation methods we will study in next lecture. Thank you.